So in this video, we're going to talk about how to make FPS games in Unity. The reason why we have this video is because there are quite a lot of FPS tutorials on YouTube, but they're mostly for making prototype or demos. And if you're going deeper into making an actual FPS game, you probably would find facing a lot real issues. I've been making FPS frameworks for some time, so I want to share some of the ideas and tricks, and I don't have time to make a pretty long tutorial for each line of code, so I made this PowerPoint as a GDC-style presentation. So as a GDC-style presentation, I'll introduce myself first. I'm Ryan Bai. I've been working in Perfect World in Beijing for some years, but we don't make FPS games in the company. And I also work on my solo projects. Currently I'm making a FPS zombie game. And here is the goals we want. First off, there are so many kinds of FPS games, and so many ways to make FPS games. So it's not about right or wrong how you do things differently. But there's always some essential things we need here. First, we want a reliable FPS system. And we need the game to be smooth and responsive. Then we need a full body of the character model. Also, we're not doing like AAA level animation-driven workflow, and we're not going to talk about details of gameplay, as there are already a lot of tutorials about that on YouTube. This is the overview of the video. Before we get started, I have to say that I have never worked in a large FPS project. Nobody told me what to do, so all these tricks are based on my own understanding and experience in my solo projects. And each FPS game might differ from each other, so it probably can't apply to every game, but it can still give you some ideas. And another thing is the terms player and character in this video. Player means controller and logics related stuff, like input, movement, player status like health and weapons. Character stands for visual presentations, like the models, animations, and IK. It's just my own custom, so you won't get confused in later parts of the video. Let's see the solutions of FPS games. Actually, there's nobody tells me this, but you could often see a lot of FPS games or FPS frameworks generally going differently in these two paths, the art-driven and code-driven. The art-driven is that you have a full-body character which contains a camera bone near the head, and your first-person camera will be under or driven by this camera bone. What you see is what you can see from the head of the character. It's quite a realistic way to make FPS camera and very often seen in AAA single-player FPS. The artist will make models and animations, and these will decide how the camera swings in-game. It requires very high-quality animations and might be less responsive for gamers to control. The code-driven is that the first-person camera will be controlled procedurally. The first-person hands, full-body character and first-person camera will be all under character rote. They're merged together by code to give correct visual result. And you don't need a full-body character if you don't want to. The camera. Instead of calculate the rotation of camera manually, I use an easy way to control camera, make the hierarchy of camera as a turret-like structure. You have a yaw and pitch transform as parents of the camera. So each axis will be rotated separately. It's very simple and reliable, and if you want to give extra modification to each rotation, it would be very easy to do. The camera smoothing. We have a lot argues about if mouse smoothing is good or bad over the years, but gamers don't know what smoothing actually works. We as developers don't know either, as each game might have different way to do it, and they all call it smoothing in the setting menu. Some really sucks, some works actually pretty good. Some games already have smoothing during hardware input. Some games can have smoothing turned off, but they still have an internal smoothing to make the control feel good, which gamers don't realize this at all. So let's say on Windows, first we turn off the mouse acceleration entirely. If you don't know what mouse acceleration is, you better know it before making FPS games. Now we use the mouse X and Y values and apply it to the camera directly. Any tiny movement on the mouse pad will give your camera a little bit itchy moving result. Then I keep track mouse movement of the last few frames and calculate an average mouse movement, apply it to the camera rotation as a way of smoothing. It actually works pretty good. The itchy feeling is gone and you can still do flicker shots in-game. Here's the averaged frames of 3. I use an array and index to keep track of the mouse input each update. The index would go 012012 like that. Another way is to use interpolation. Use a variable as the final result of mouse movement, and interpolate it to the mouse input of current frame in each update. Then use this variable to apply to camera rotation. I've seen people doing like this, but it will feel slippy in some cases. So I would suggest just to use the average frame solution. Movement solution. Kinematic Character Controller is a very good asset from Asset Store to replace Character Controller of Unity. It has a very easy ground check to know if you're on the ground or in air, so you don't need to do it by yourself. It still works correctly when running up or down stairs as well. And it supports all directions gravity, like if you want to make a sci-fi FPS that might have different surfaces to walk on. And it would handle slip off the edge very good. The downside is that Kinematic Character Controller works in fixed update by the physics way, so it's not very good to handle rotation for FPS. So the mixed way to do is to use code to rotate the camera by yourself, and use Kinematic Character Controller to move the player. You should never change the Kinematic Character Controller's rotation, which by default is quaternion identity. And by the logic, the direction of the player should be decided by the direction of your camera. Here the simple workflow is that your own camera controller will apply mouse input into camera rotation. You'll write your own movement controller to give movement input to Kinematic Character Controller, which will handles it automatically. Then in fixed update, update the camera, first-person hands and full body's position to follow the player's actually position. Animation solutions. Let's say we will just use Unity's default animator controller to do the animations. We need all animations to be transitioned smoothly, so always use Crossfade API to do it. And we need animation state that can crossfade to itself. For example, when doing a melee attack repeatedly, you want to play the same state from start by with smooth transition. The good news is in Unity 2020, you can crossfade to your own state by code. And for animation events, there's a nice asset called Animator Events that can add events to animation state in Animator Controller. It supports different type of event, like state enter, state exit. It supports trigger events at normalized time. And it can be toggle if you want the event to trigger during exit. For example, you have an event at half of the reload animation, but you do some other action to cancel reload, and you don't want the event to be trigger if you cancel reload already. So just untoggle this, the event won't be called during animation exit. Then, always use code to switch between the states. Here the reason why. For example, you're playing an unarmed running locomotion, you want to switch to rifle running locomotion. In your old locomotion, your right foot is at front, and you want when start play the new locomotion your right foot should also be at the front. If you use the graph condition between the state machines on Animator Controller to switch states, the destination state will always start at 0 or a fixed offset. This will cause the feet go wrong during transition. The glitch might be very obvious and can't be ignored. But if you use code to crossfade to a different state, you can set it what normalized time to start within the target state machine. Also, when setting animator parameters to cause condition transition, the transition might be delayed for a few frames as they're called in different internal updates. This would cause glitch-like if you want to enable a certain layer and trigger a transition in it at the same time. The layer can only be enabled by code and it's done instantly even by interpolating its weight, but the transition might be late for a few frames, and there might be 1 or 2 frames glitch showing a wrong animation. And there's a bug that I've met that the trigger parameter sometimes don't work in multiple layers. So the graph condition transition isn't a reliable way to switch states in Unity. Make good use of blend tree. Like, my character locomotion have 2 layers of blend trees. The idle is at the same layer of walking and running blend tree. The reason for this is that when strafing from left to right, there's a brief moment the speed is 0. But I'll keep blend tree on running when quick changing strafe direction and it won't goes back to idle when speed is 0. If you take time to think about it, you can have a more complicated blend tree for locomotion. Also a lot of state machines can be used to blend tree if you have sufficient animation clips. When play turning animations, use turn left and turn right as a blend tree, use the angle as its parameter. So for different angle, it will give the correct turning correspondingly. First-person hands can have idle and aim down side idle as a blend tree as well. Anyway, when you design animator structure, you can have an extra try if it can be used as blend tree. Use multiple layers for complicated logics. Like showing rifle, I'll play the show rifle both on base and upper layer at the same time. Because base layer show rifle is a in-place full body animation, and upper layer is a upper body mask of the same animation. So when playing show rifle, suddenly the players start moving. The base layer show rifle is gone and upper layer show rifle is still overriding the upper body. Layers have too many ways to take good use, you can have quite a lot layers for different result. I won't go too much about as it requires a dedicated design for the project and different type of additive animations to work with. Use parameters to control play speed of the state. I think a lot of people already use it. And it can be used for quicker reload animations. Animancer is also an animation solution from Asset Store. I added to the PowerPoint as I've been using it since the first version. It's a replacement of Mechanim, the Unity animator controller. And it does have some shining points. You can create dynamic animation states at runtime. The states can crossfade to itself, which was an extra point over Mechanim before Unity 2020. Unity has jitter problem when switching quickly between two states repeatedly, but Animancer don't have this issue. But there's still some cons about it, you cannot crossfade a mixer state to itself. Event system and layer weight fading sometimes fail to work, which means you have to have your own workarounds. And it's not as stable as Unity's animator controller, it doesn't support empty state. And it requires you to write a lot of codes. So I've already switched back to Unity's animator controller since Unity 2020. Well, Animancer is still an option if you're interested. So let's see the general structure of first-person hands. The camera is under the character root transform, a weapon root transform is under the camera. Each weapon is a transform under the weapon route. Then when switching the weapon, there would be one weapon set active, and the rest will be inactive. And for each weapon, it can be hands model with weapon model together, with just one animator at route, and they use the similar skeleton and avatar so you could change the mesh dynamically. Or use a general hands to spawn for each weapon, and also a different weapon model for each weapon, and weapon model should also have an animator and related animations of it to match the animations on hands. The picture shows weapons from low poly shooter pack from Asset Store, which also contains an older version pack. If you have this asset, you'll see how they design the art workflow. I make my FPS framework that can work with only 3 animations at minimum: idle, reload, and fire. Other behaviors show hide weapon and bobbing can all be done by code procedurally. And I also support using extra animations as an option to play show, hide, inspect, blend tree idle and firing. For the idle, I put the weapon in the hierarchy and find the best local position and rotation for idle to be seen in the camera. Also the position rotation for ADS, which is aim down sight, the weapon still plays default idle animation, but ADS position would put the weapon close to camera to make it look correctly. Even if you use an animation as ADS idle, you probably would also need custom ADS position for different optical sights. Because they need to show the front sight to be close to the middle of the screen. FPS Player. This should be the core component of your player controller. You could have as many variables to keep track the player status if needed. Like if player is standing or crouching? Is moving or not moving? What's the speed threshold to differ moving? Is playing sprinting, ADS, reloading, attacking, in air and more? And a lot of your player behaviors will take consider of these status. For example, do you allow reload when sprinting? If you don't, then when you press reload button, you should check if you're sprinting. Do you allow crouch when in air? When you're sprinting, would reload or attack will cancel the sprint? Do you want ADS as toggle or hold? Do you want sprinting as toggle or hold? When you are in switching weapon, do you allow a new switch action to activate over it like quickly pressing Q in Counter-Strike? And if you don't have a global ideas you how your behavior rules would be, you could see the details of other FPS games, and make your designs ahead of time. It's very important that you make clear decision of how your game would be. It'd be very troublesome if you want to add new behavior when the progress of your project is at halfway, like, if you never consider about climbing ladders, and it would be very risky to add ladder when you almost finished the game. Because I code to control the bobbing of first-person weapon procedurally, I use a global curve for bobbing, I call it bobbing curve. The player controller will maintain this curve in each update. The range of the curve is from 0 to 360 degree in angle, then goes on from 0 again. It will consider the speed of movement, like if you're moving fast the curve will increase fast, if you're moving slow the curve will increase slow, if you're not moving the curve won't goes up at all. Because the curve is between 0 to 360, the sine and cosine of it would be continuous and friendly for controlling bobbing like swing weapon left and right. For each weapon it will contain several bobbing behaviors, like idle bobbing, yes, idle bobbing. If you had just a static bobbing pose instead of animation, then you'd need to use code to swing the weapon when in idle, so idle has a bobbing as well. Then strafe bobbing is for strafing left and right, run bobbing is for running, sprint bobbing is for sprinting, ADS bobbing is for ADS idle, jump bobbing for jump start and jump end. All these bobbing have their own values like position and Euler values for the maximum effect it will give to the weapon. And each of them will calculate these results by the global bobbing curve, and also consider what player status is. Usually the result is calculated by sine or cosine, you could have extra modification as well. And in each update when the calculations are done, the weapon add all bobbings positions and rotations additively to the parent transform to make it act like swing the weapon. Now there's a very important thing we have to talk about, avoid clipping into environments. A lot tutorial will tell you to use 2 cameras, one for the environment, one for the first-person weapon. Just don't do this way as it's very troublesome if you want correct shadow casting, and double camera might give you a lot extra draw calls. So as a replacement I'd recommend using this asset from Asset Store, the first-person view. It uses a shader way to make the weapons rendered over environments, and shadows still works correctly, and all objects are rendered in just one camera. See, here's a goal we want, like in every FPS game. 1. Your first-person weapon shouldn't cast shadow to environment as you don't want to see a shadow of hands in air on the ground, that's easy, we just turn cast shadows off on the meshes. 2. Environments can cast shadows to your first-person weapon, which means your FP weapon and environments as layers should all be in the light-supported layer masks. If you're using HDRP they all should be in the light-supported light layers, which means if you're using 2 cameras to rendered by different layers, this won't work. Your environment won't cast shadow on weapon. And only the first-person view can work this out. 3. Your first-person weapon should always render over the environments. Yes, first-person view can do that in just one camera. And there's another bonus feature, it has that FPV plugin supports an inactive camera to control first-person weapons field of view. This is very helpful when you do ADS, and you could also avoid glitch to see outside of the first-person weapon if player change the default camera's FOV. Fast making FPS hands. This is a fast way to create first-person hands and weapons within Unity with the assets you can get from Asset Store. So first, assume you're not an animator or 3D artist, at least not a professional one. And you have some characters, and a first-person package, but the hands doesn't match your character. So you want to use your character's meshes and the first-person package's animations to create a first-person hands and animations that matches the character. So how do you make animations without making them? See, here are the abilities we have in Unity. We can use editor scripts to create meshes from existing meshes and, with Unity API, we can use editor script to create animation clips. And we can use inverse kinematics, which is also called IK in Unity. So the conclusion is that we can use IK to play animations and record them into animation clips so we could have animations for first-person hands. Then here's the assets we need. You could use alternative solutions like writing your own codes, but this is a fast way to go forward. The final IK, it's the best IK plugin you have on Asset Store. The FPS Mesh tool, which can cut a humanoid character into parts of head, hands and body. Puppet Master, we don't use Puppet Master here, but it has some amazing scripts that can bake any movement of transforms into animation clips. Umotion Pro, it's just what I use for post-processing of the baked animation clips. If anything don't show correctly, I'll use Umotion to modify the animation a little bit. So you could use any alternatives if you like. First we use FPS Mesh tool to cut the hands out. You'll assign the head and upper arm bones to the editor window. It will be done in just one click. We can control the result with head and body set to invisible shader. We just need the arms for first-person hands. It's a FPS hands with weapon, from low poly FPS pack on Asset Store. Its animations will drive our hands to move, so I'll put this FPS hands under our character's rote. Our character's rote should have no animations to play. If it has an animator component, just set the animator controller to null, so our hands can be freely controlled by IK or in Unity Editor manually. Then we set the IK targets on the FPS hand skeleton. Both right and left hands bones should have a child transform as a IK target. Then we'll have two limb IKs of final IK, set their target and some other settings. I won't go too detailed about final IK as they have a lot tutorials and very easy to use. Then we run the game. The character's hands is now controlled by the IK and follow the FPS hands. We'll alter the position and rotations of the IK target so the character hands should be placed correctly, write down the values of their position and Oilers and set them back after the run stops. We'll also need to adjust the finger bones of the character, like the left hand fingers should grab and hold the weapon, the same with right hand fingers to grab the grip and hold the gun trigger. Then we need to add the generic baker from Puppet Master. We add generic baker component to the character's root transform, set its mode to real-time because we need to bake the animation at runtime. Like when we play Reload, we'll bake all transformation data of all bones in the entire hierarchy as a new reload animation. Then we play Shoot, we'll bake a new shoot animation. However, the generic baker cannot be used directly, you need to write a custom code to call its function to work. Like how much time you want to bake, what name you want the animation clip to be, and when to bake. In my own project, I create a script that can read all animation states on the FPS hands animator and select a state to play and bake it. After baking, you would have the result animations clips. And during baking processing, you could have more settings to adjust your character, like you probably should rotate your character's chest bone to make your left shoulder forward a little, and you might want to animate the bend goals of limp IK during baking. As we don't have a default animation to play on the character rote, you can freely adjust the character's bone if need to have better baking result. Then after all animations are done, we'll delete the default FPS hands mesh and use the weapon and our character's hands, and save them into one single prefab. Then as a final process, I'll adjust the animation in Umotion if there are glitches of meshes. Then we can use the final result in game. The entire workflow might sound like a daunting task, but it's definitely doable, and once you break through this workflow, you're totally unstoppable, as now you can use any character and first-person animations on Asset Store to create your own animated FP hands for your game. However, there are still some cons about the workflow. As your character hands are driven by IK, the result might not be perfect, like the wrist might be twisted in some cases. And if you want better result, it will still take more time to polish it. But it's already a boost for you to create animated FP hands in Unity, then create them from scratch. Fullbody System. Fullbody is the character model that will be only seen by the player himself when he looks down. It's not like the other player's character model you see in multiplayer games, and it's not like the character model in third-person games either. So I call it full-body character as a distinction. The full body will be under the character root transform to follow its position and rotation. Here are the goals of Fullbody System. We need the head and arms invisible, as you don't want to see a head mesh moving in front of your camera. And the full body should cast shadows on the ground, including head and arms. The full body should match camera height convincingly. I mean, convincingly doesn't mean exactly. If it doesn't look too weird, then it's okay. Camera should avoid clipping into full body like when looking down, or play animation. full-body character should have aim direction correctly with your first-person camera, even though you can't see your full body's arms and head, but they have shadows on the ground so you don't want it to be too weird. First, let's see. The FPS Mesh tool already provides a shader called Invisible Shadow Caster that can make your head and arms invisible, but still cast shadows. And we'll keep cast shadows on the full-body skinned meshes so they could have shadows on the ground. Then instantiate the full-body character model under Character Root Transform. The size of full-body character can be smaller than the capsule and lower than camera position. But when directly looking down, your camera will see the open neck of your body, so we need to fix it. In some games, the camera might be at head position when you look to the front, but its position isn't exactly at the head position when looking down, it can be at front of the full body's chest or at the waist. So players can only see the legs or some of the belly. Some games also would set a limitation angle to stop player from looking down vertically. In my project, because I want players to see their customization of the character, it'd be quite shame if they can't see the clothes. So the camera must be able to look directly down. So I use a camera offset curve as a workaround to solve the issue. By the look-down angle, the camera will move to an offset forward and downward. So when players fully look down vertically, the camera's position is at the front of the head and some distance to have a complete view of the upper and lower body. And for different locomotions like unarmed, rifle, pistol locomotions, the camera have different look-down offsets correspondingly. Even for different status like running and standing in place, the offset would also be different. And for the full-body animations, try not to use any animations that sway the body a lot. Because I use the code-driven path to control the camera, the full body has to behave gently without cause glitch. So I don't have sprint animations and jump animations in the full body in my game, because sprint and jump animation assets swings too much and cause glitch. Actually, I could use IK to snap the full body's head bone to a fixed area, but use only running animation already works fine in my case. Full body character state machines can be similar to a third-person character, but it could be much less detailed. I won't go too much about the implementation, but I still recommend to use code to control state switching. And I will talk a little about aiming with IK. This part can also apply to third-person or multiplayer characters. We'll create an aim target transform and put it at a far distance away along the camera direction. And the full-body character's hand would always aim to this target when holding a weapon. In Final IK plugin, I use a biped IK and aim IK for this. You can also find how to do aiming in demo scenes of Final IK. The weapons is under the right hand bone. And I use biped IK to match the left hand relatively to the right hand with an offset. So the left hand could be placed near gun barrel correctly. And if the right hand moves around, the weapon and left hand will be moving by the right hand as well. For different weapons, the values of these settings should also be different. Then I use aim IK for right hand to aim. It requires an aim transform as a reference to start aiming, which should be near the rear side of the gun. And use the aim target transform as aim target, which is where the first-person camera looks at. Then when biped IK and aim IK work together, you would have a correct aiming result of the head and arms. Please note that if you're playing animations like reload, show hide weapon, you could disable the biped and aim IK. Or have animations work correctly if aim IK is on. In Call of Duty World War II, when you reload your IK is disabled, then when reload is done the IK is back on. And for better result, you could have blend tree of aim poses as an override layer. The aiming pose will change by the angle you look right and look down. The angle might not be precisely as what it appears to be, then you could scale the parameter a little when used this way. Then let's see the turning animations. Turning has always been a complicated thing in FPS game. Well, in most cases, multiplayer character and full-body characters are both less detailed than the character in third-person games, so the turning don't need to look too precisely. But FPS games have a hard problem that your camera may rotate at very high speed, especially with a mouse as input. But in third-person games, you could always give the character angular speed as limit when character turns around. So in FPS games, there are a lot to consider. First, let's see the basic turning rule. In the condition of standing in place, we'll no longer keep the full body character always rotating along with the camera. If your camera rotates, the full body character will still stand in place, no rotation. And the aim target or the look target will always be at the direction of where your camera looks at. Look target could the same like aim target when aiming, but I'll call if look target here because this part more focused on horizon plane. Look target is where the camera looked at position projected onto the horizon plane, which is the XZ plane in Unity. And we would use it to make character to face the look target. So when turning camera, full body character will try to look at the look target without changing rotation of itself. When player not holding a weapon, use look at IK from Final IK plugin. Then let's see when the look target moves around, the look at direction will rotate left and right. We'll use an angle limit as boundary to determine when we should turn, for example, the 120 degrees area in front of the full body character. When the look direction is inside this angle boundary, the full body character stands still. But when the look direction is over the boundary, it's time for the full body character to turn. For turning implementation, I use quaternion interpolation of the full body character. It will interpolates to the look direction in each update at a slow speed. At the same time, full body character plays a turning animation at the same time in the blend tree way. The blend tree is made of turn left 90 degrees and turn right 90 degrees, with a parameter of the turn value which stands for the angle of how much you should turn. Then the turning is done. The basic turning is simple, but here's the hard part. What if when doing turning behavior, my camera is still rotating fast? You might need to break the current turning and turn to the opposite direction. Or when current turning is done, keep turning at the same direction on and on. This sounds reasonable, but take time to make the code tidy with all the mess. And what if we keep rotating the camera really fast, very fast like you set mouse sensitivity to max in Counter-Strike and shaking the mouse? And at this time, there's barely no way to determine what direction to turn and when to turn. So I make a workaround to solve this that I'll keep track of the rotation speed of first-person camera in each update, and use the angular speed of camera to determine how fast full-body character should follow the look direction. The faster your camera rotates, the faster your full-body character follows the look direction. And if the speed is over a threshold, we don't play turn animation at all. So you'll see the full-body character looks like it's always snapping to the rotation of your camera. This might sound confused, but I've seen other games behave like this. About weapon aim, I use the side aim and center of screen aim at the same time, and they are interpolated by the ADS value, which is how much you hold aiming down the sight. First we have a transform at the position of front sight of the weapon. If you use optical sights, it should also be at the middle of optical glass. When shooting the gun, we'll have a shoot direction from the camera to the center of the screen, which is actually just the direction of the camera. Also we create another shoot direction by the position of camera and the position of front sight, which is the line is for aiming down sight. Then interpolate these two result by the ADS value. When you're fully in hip fire mode, the ADS value is 0. When you hold or switch to ADS mode, the value goes up in between, and when you're fully aiming down sight, the ADS value is 1. So the interpolated result would be the final shoot direction we use. This direction is where we'll shoot the bullet forward if no bullet spread. And for recoil and spread, there are plenty ways to make good recoil and bullet spread. Some games have very classic spread patterns for different weapons, so gamers would have nice muscle memories. I do these in simple ways, so it probably won't apply to your game, but it might give you some idea. To create recoil, I use just a kick and a swing to rotate camera. When you fire a weapon, the kick value goes up by the weapon setting, and a random swing is generated between swing left and right. These two values will create an additive rotation for camera. It also considers restore strength. If the shooting stops, the restore will make the additive rotation back to Euler 0, 0, 0. For bullet spread, I just use a single angle value for the bullet to affect the shoot direction, so the bullet will drop circularly around the ideal shoot direction. And the strength will goes up by how many bullets you just fired. And there are multipliers for different player status, like for standing, crouching, running, jumping, ADS. They all have different spread multipliers to multiply with the spread angle. Example: if you want when aiming down sight full, there should be no spread at all, and if you're in hip fire and running, the spread should be pretty large. And some extra tips about camera rotations. Even though I use the code-driven to control everything, I still have an animation-driven feature for the first-person camera. For example, when you reload the weapon, the camera will rotate by the animation correspondingly. So let's see, we could find the camera bone inside the first-person hands, and we'll keep a reference of the camera bone. At default, the camera's animation driven is off, but when it's on, we'll calculate its local rotation by the weapon's root bone, then we'll apply this rotation to the first-person camera. When you apply the rotations to first-person camera, it's added additively. This also includes recoil rotations, shaking rotations. So it's pretty much everything of the video. In short, you should make determined designs of the FPS player ahead of time, even maybe before you create the project. Go to see how other FPS games do. Don't go to see the AAA game in recent years, because a lot of them might use motion matching or super complicated logics, so it's impossible to guess how they do things. You could use a global bobbing curve to create bobbing procedurally for first-person hands. And use first-person view plugin if you don't have a better solution. You could use the Unity itself to create first-person hands as a quick workflow. And some tricks about using full-body character. Thanks for watching.